Non-inertial frame. Non-inertial frame. Non-inertial frame. Non-inertial frame. Fictitious force. Fictitious force. Fictitious force. Non-inertial frame. Fictitious force. Fictitious force. A frame of reference in accelerated translation motion with respect to an inertial frame is a non-inertial frame. A frame of reference. A frame of reference. Of reference. A frame of reference in accelerated translational. In accelerated translational. Translational motion with respect to an internal motion with respect to an inertial frame is a non-inertial frame. An inertial frame is a non-inertial frame. Non-inertial frame are fictitious force. A frame of reference in accelerated translational motion. With respect to an inertial frame is a non-inertial frame. Moreover, a reference frame in uniform rotation with respect to an inertial frame is also inertial frame. A reference frame in uniform rotation. A reference frame in uniform rotation with respect to an inertial frame. With respect to an inertial frame. With respect to an inertial frame is also non-inertial frame. Is also non-inertial frame. A reference frame in uniform rotation with respect to an inertial frame. Is also non-inertial frame. A reference frame in uniform rotation with respect to an inertial frame is also non-inertial frame. A frame of reference in accelerated translational motion with respect to an inertial frame is a non-inertial frame. In a non-inertial frame, an operator or fictitious force appears to be acting. Let us consider both the cases and the origin of fictitious force. Consider an inertial frame S. Consider an inertial frame S. This is the y-axis This is the y-axis, y-axis, and this is the x-axis. This is the x-axis. This is the y-axis, and this is the x-axis, and this is the z-axis, and this is the origin O. This is the origin O. This is the origin O. Consider an inertial frame S. Consider an inertial frame S with respect with its origin O. With its origin O. Let us S dash be the another frame. 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 Another frame. S dash be the another frame. With respect to O dash. With respect to O dash. With respect to O dash. Another frame with origin O dash. With origin O dash. Moving relative to O. Moving relative to O. Moving relative to O. With uniform translational acceleration a0 when the origin O dash and O consider let us t dash equal to 0, and this is the point P. This is the point P. And this is the y dash, and this is the x dash, and this is the a0, and this is the z dash. This is the z dash. This is the z dash. Vector r 1/2 a0 t square. a0 t square. Suppose the frame S dash starts. Suppose the frame S dash starts. Suppose the frame S dash starts from rest. Then displacement O dash. Then displacement O dash of the origin O dash in time t. In time t equal to 1/2 vector a0 t square. Vector a0 t square. Vector a0 t square. If P is a particle moving in space, if P is a particle moving in space and vector r, and vector r dash, vector r and vector r dash are its position vector at time t in the frames S, and S dash respectively, then OP vector OP equal to vector r and vector O dash P dash equal to vector r dash. Vector O dash P dash equal to vector r dash. Vector r dash. O dash P equal to vector r dash and OP equal to vector r. Now vector OP equal to O dash vector plus OP vector plus OP vector plus OP vector plus OP vector O dash P vector OP vector. Then the value is O dash vector O dash equal to vector R dash vector R equal to OP means vector R. Okay, means vector r. So o dash, vector o dash plus vector o dash t, vector o dash t, and the value vector r equal to vector r dash plus o dash value 1 by 2 a0 vector t square. Differentiate. This is the equation number 1. This is the equation number 1. Differentiate equation 1. Twice we have. Differentiate equation 1. Twice we have. Differentiate. Differentiate equation number 1. Twice we have d vector dr upon dt equal to vector dr dash upon dt plus a0 vector t. Differentiate the value of this a0 vector t and d square vector r upon dt square equal to d square vector r dash upon dt square plus a0 vector r ai vector equal to vector a dash plus vector a0 when ai and a dash where ai vector and a dash vector are the acceleration of the particle particle p in the frame is inertial and s dash respectively. If m is the mass of the particle, f is the mass of the particle, then multiplying both sides of relation second by this is the relation second. Then multiply both sides. Then multiply both side relation by second by m. We have ma1 vector equal to m vector a dash plus m a0 dash r. fi vector equal to f dash vector plus f0 vector r f dash vector equal to fi vector minus f0 vector. When no real force acts on the particle P in the inertial frame, when no real force acts on the particle in inertial frame, then if real force is not acting, then is not acting, then inertial frame S dash comma Fi equal to 0. In such a case F dash equal to minus F0 vector. Thus we find out that in the frame S dash the particle P appears to experience a force minus F0 even when no force is acting on it in the inertial frame S. This force arises due to uniform translational acceleration of the frame S dash and is therefore a fictitious force. This fictitious force has not been applied from outside but arises because of the frame of reference selected by us. It is therefore a non-inertial frame, and the frame of reference which is moving with a uniform translational acceleration with respect to an inertial frame is a non-inertial frame. Fictitious force. Next is fictitious force. Fictitious force. That means fictitious force. 1 minute. Fictitious force. Fictitious force. Consider a reference S dash moving with an acceleration A0. Consider a frame S dash moving an acceleration A0 vector relative to a frame S dash. Relative to a frame S dash. Will be non-inertial frame and vice versa. Will be non-inertial frame and vice versa. Now consider a particle of mass m on which no external force is acting in. Now consider a particle mass m on which no external force, no external force acting on it. No external force acting on it. No external force acting on it. Acting on it. 1 minute. The reference S, then the acceleration of the particle in the frame S is 0. Then the acceleration of the particle in the frame S in frame S, acceleration 0. Acceleration 0, but the particle will appear to have an acceleration minus a dash. But particle particle appear, but a particle appear to have an acceleration, have an acceleration, minus vector a relative to the frame S, relative to the frame S dash, In other words, to an observer in the frame S dash, a force F0, force F0 vector equal to minus M vector A0 will appear to be acting on the particle, whereas an observer in the frame S dash, there is no force acting on the particle. Such a force, which appears only due to the acceleration of the frame of reference, is called fictious force, apparent or pseudo force. Such a force which appears only due to, which appears only due to the acceleration of the frame of reference is called fictitious force. Apparent or pseudo force. Such a force which appears only due to the acceleration of the frame of reference is called fictitious force, apparent or pseudo force. It is called apparent or pseudo force, or fictitious force. Total force. Next is total force. Suppose the particle has an acceleration ai. The particle has an acceleration vector ai. As observed in the inertial frame S. Then, according to Newton's second law of motion, the force acting on the particle is given by Fi vector equal to MAI vector. When this force is observed from the reference from S dash, then the frame S dash may be assumed to moving with an acceleration minus A0 vector relative to S dash. Hence, the particle will appear to be acted upon by an additional force minus MA0 vector in the system S dash due to acceleration in the system S dash due to its acceleration. So, the total force acting on the particle as observed in the reference frame S dash. Total force total force by an observer, by an observer in the reference frame S dash F dash vector equal to MAI vector plus minus MA0 vector. That means MAI vector minus A0 vector are F dash vector equal to Fi vector minus F0 vector, which means that to an observer in the frame S dash, the total force acting on the particle appear to be F dash, and net acceleration A vector minus A0 vector, the force F0 vector equal to minus MA0 vector is clearly the fictitious force. Is clearly the fictitious force. This force does not actually exist. This force does not actually exist. But appears to come into being only as a result of the acceleration, of the frame S dash, with respect to the frame, hence fictitious force, F0 vector equal to mass multiply acceleration of non-inertial frame with sign reverse. Acceleration of non-inertial frame with sign reversed. That means M minus A vector 0 equal to minus M A vector 0. This is the fictitious force. Newton's second law of motion will also good in a non-inertial frame S dash will behave as an inertial frame V. If we add to the true force Fi, a fictitious force F0 equal to minus MA0, and take the total force F dash equal to Fi minus F0, and the total acceleration, and the total acceleration acceleration, total acceleration vector A dash equal to vector AI minus vector A0. This example of fictious force as given below. And an interesting example of fictious force is that of centrifugal force. Centrifugal force. Consider a point mass m at rest in a non-inertial frame. AI बराबर 0. Suppose that the non-inertial frame rotates uniformly about an ellipse with respect to the inertial frame. The acceleration at the point mass with respect to the inertial frame can be written as centrifugal force. One minute. Centrifugal force. Centrifugal force. An interesting example of fictitious force, that of centrifugal force. Consider a point of mass m. At rest in a non-inertial frame. AI vector equal to 0. Suppose the non-inertial frame rotates uniformly. About an fixed with respect to the inertial frame. With an inertial frame. Non-inertial frame, and inertial frame. Non-inertial frame. Suppose a non-inertial frame rotates uniformly about an fixed with respect to the inertial frame. The acceleration at point y with respect to the inertial frame can be written as A0 vector equal to minus omega square vector r, where vector r is the position vector of the particle and directed outwards to the particle frame, the axis. Now f dash equal to fi vector minus f0 vector equal to 0. So f dash vector equal to minus f0 vector equal to minus ma0 vector equal to minus m omega square r square. Example 2. Coriolis force. Another example of fictitious force is the Coriolis force, which acts on a particle in motion with respect to a rotatory frame of reference. And we are studying in the next heading of the Coriolis force example. Okay, thank you.